Quickly, we'd like to address kilovoltage, or kV, and attenuation, which is simply what happens with the interaction and absorption of the beam as it comes from the tube and it goes through the patient. This kV is considered the quality or the penetration of the beam. As you increase kV, you increase penetration and you increase quality. As you increase the kV, what you're doing is you're increasing the amount of radiation that's going to reach the image receptor. And this can be really good if you want to help to save dose, but it also can decrease your contrast. So we have to be real careful how we balance that. With digital, we have a lot more leeway than we ever did with film screen when we're looking at increasing kV in regard to contrast. So now we can use higher kVs than we used to be able to use and not worry so much about the contrast, because so much of the contrast is actually taken care of by the computers. Attenuation has to do, again, with what happens when the beam goes through the patient, and it has to do with the absorption processes and the interactions of the beam as it comes towards the image receptor. And almost 99% of the beam will be attenuated by the patient, with only 1% actually reaching the image receptor. When the beam goes through air, there's very little interaction at all. So it goes basically straight through. With soft tissue, you see more interaction and you're going to see scatter. With bone, we tend to see more absorption than we do interaction. This is what gives us differential absorption, or what gives us the image, because if we didn't have absorption with some parts and interaction with other parts and direct throughput with some, we wouldn't actually have an image to even look at. This particular illustration is just showing you the size of the beam as it comes from the tube, or what we'd like to call the intensity or the quantity of the beam as it comes into the patient. So you can see as it's entering the anterior portion of the patient that there's quite a bit of it, but there's all this interaction and absorption as it goes through the patient, and you only have a very little bit coming out. Like I said, usually about 1% of the total beam.